or not the percentage, but the decimal. So
You do a decimal, but also, since there's only 2 children here, can't you do a tree diagram? It's not going to be 2 units.
Yeah.
So let's imagine first child could be a boy or a girl. First child could be a boy. Or sorry, the second child could be a boy or a girl. Boy or girl. And that pretty much represents the entire story. Now we need to put in some numbers. The chance that you have a boy is 0.536. And the chance then that you get a girl, isn't a girl like the complement of a boy?
So I would do the -1 minus that number.
And I believe it's 0.646. It's 464, but you can double check.
Yeah, 0.464.
Okay. Now, since these are independent, yeah, sorry.
So
since these are
I have to do it all over again, right?
Yeah, basically just repeat yourself.
So
I was going to say,
0.
since these are independent, you can just duplicate the tree, which kind of makes your life a little bit easier because remember the voting for X and Republican and not Republican, the numbers kept on changing on you.
Yeah.
It's a little bit simpler because you don't need that.
That's like it's similar to the concept of the elimination versus the not elimination, right? Where you have
it's
to
kind of change the number each time.
It's the same independent for each child, then you don't have to minus out one less or do it. It doesn't change that probability.
You nailed it. That's exactly correct. Now, in this question, since we're only
when they have kids to realize that your chances of having a boy or girl didn't change that much.
Not really.
Everyone always likes to say, "Oh, if you have 3 girls, you have to get a boy next." No, actually, you don't.
No, well, as I told you about my sister Morag, she wanted a girl, and she got 4 boys and then gave up. And I think I also mentioned to the class, if I didn't, every single one of her boys, the first child, was a girl. So go for it.
And on this, I would still compute out what those would equal out at the end, right? So that I have the number.
Typically, you would if it was a big question, Tara. But I'm just looking. This question only asks one thing. So if I want to save some time, let's do that. Probability of one of each. Right. Well, that would be what a boy and a girl, which would be this one, and a girl and a boy, which would be that one. So I guess I only need to find these 2 probabilities, right? A boy and then a girl, that's one of each.
And then you would add them together to come up with your complete
answer. You've nailed it again, yeah. So 0.536 times 0.464. And I get, do we need a rounding off here? 4 decimal places. I get 0.2487, but you want to check that?
Yes, I'm right behind you. I was writing my note to myself of like, if I have more options for an outcome, you have to add them together. So that way, whenever I come across a problem that is giving me more than one option of an outcome, that probability, then I know to add those probabilities together to come up with the chances. Okay. So on this one, I'm looking for.
We'll be with you shortly, Tina. As soon as this one's finished, I'll get your question.
Not a problem. Thank you.
You're welcome. Right, you want to double check my number crunching when you get time, Tara? I have 2, 4, 8.
Yep, I thought the same thing.
And so when you double it, you would get 0.4974, I believe.
Yeah, 497.4.
Right, it's time to move on. Tina, what's your question?
I'm in your first class, by the way. Chapter 9, sampling distribution.
Okay, let me get there. Chapter 9.
For proportion.
Oh, okay, that's nice and. You're right. Did I forgot?